Hey everyone, this video. I know this is very exciting. So what I've done is I've written a ton of questions that we're going to go through, and then you should be set for the final. So I'm trying to think about your best strategy. Maybe watch me do them, and then you go back and then you just try them all without looking at your work. And then go back and watch the video again to see how you did and see if they made sense. Maybe that's the best kind of strategy, but if you're set with these questions, you'll be set with the ones that are on the final exam. All right? So Module 4 is all about lines. And one of the questions you're going to be expected to answer is how can you tell if a line has a change or a slope, remember the change and the slope are the same, that's positive or negative or zero. And I said, well, you can look at the line and know if the slope's positive or the change is positive, negative, or zero by what the line is doing. So if you start on the very far left of a line, we read a line just like a book, we go from left to right. If you start on the far left and ride the line, if your pen is going down, that is what is called a negative change or a negative slope. All right, so I start at the left, and then I'm going to start reading the line. As I go from left to right, if my pen is rising, we have a positive slope. If I start at the left and I go from left to right and my pen is not rising nor falling, that is a slope of zero. Remember, the slope is a change. There is no change, right? Nothing's happening. It's not rising nor falling. If I start at the left and I read my line as I go from left to right, if your pen is falling, or if your pen is rising, you have a positive slope or a positive change. All right, so for a linear equation, you add or subtract a constant for each increase in the input. The value you add is called the slope. So this value is a constant each time. Now you guys might remember, maybe not, in a previous math class, y equals mx plus b. That might be like floating around in your brain somewhere. Or y equals b plus mx. If you do, then that is the equation of a line that's kind of stuck in your brain somewhere. I'm going to refer back to that and explain what the m and the b are. But this, if you guys can remember what's down in this box, you'll be set. So I like to say that the line is a starting value. So here's my starting value. Okay, it's a starting value plus or minus a change times my input. Okay, the starting value on your graph is your y-intercept or your vertical intercept. So the starting value is your vertical intercept. Okay, the change is, let's go back. When we were talking about the phone plans, the change was adding $10 every time we increased a gigabyte. Or when we were talking about the latte, the change was decreasing by $2.63 every time we purchased a latte. So it's a change, and x is your input value. Okay? All right. So this is the starting value. The change is our slope, and the x and the y are, that's my input and that's my output. All right. Now you might have remembered mx plus b. Well, y equals mx plus b. If you don't remember this, then completely ignore me. The b is your starting value or your y-intercept, and m was called the slope, or the change. I tend to write them, I flip this because addition's commutative, so I always do the starting value first, and then the slope or the change. So we're going to go back and forth where we're going to flip those around. All right? Okay. So the starting value, or the initial value, is that vertical intercept in the form of 0, comma, you might call it 0, comma b, 0, comma y, right? Your starting value on a graph is up here at this y-intercept, okay? And you will get this. You just got to give me a little bit of time to work through this with you guys, okay? So, for example, this would be my starting value. This would be my starting value. This would be my starting value, because it's the start of the graph, and that would be my starting value. All right? It's just the vertical intercept. We have a positive change, negative change, and a change of 0. All right, so let's look at some problems. I promise you'll get it. We just got to go slow. All right, so a man goes on a diet starting after New Year's Day. Here gives the his weight at T number of weeks after January 1st. Okay. So what's happened? So does his weight change? First of all, does it change? So if we look at his weight, you say, yeah, it's definitely changing. Is it changing at a constant rate each week? Well, from here to here, it went down 2 pounds. From here to here, it went down 2 pounds. And from here to here, it went down 2 pounds. So yes, the change is a constant, right? So my slope of my graph would be -2. So according to the table, the rate of change of his weight is correctly described as, well, he loses 2 pounds per week. Okay? So the change is always written as a fraction. So this will be -2 pounds per 1 week. Every week he loses 2 pounds. So there's my change, right? The slope is always written as a fraction, right? So that's one thing we got to get down. So what it says, what is the value in the units of the vertical intercept? Now remember, the vertical intercept is the starting value. So what was his starting weight? Looks like his starting weight was 206 pounds. Right? Okay. It says make the linear equation used to describe the data. Okay. So the input's going to be the number of weeks. So this is T. And the output's going to be the weight. So the weight is going to equal the starting value, and then what the change is negative, minus 2 pounds, right, every week. Starting value, the change is negative, so minus 2 each week. Time is in weeks. How do we do? Does that make sense? All right, let's try another one. Sam is hired at a small sales company. His monthly pay is calculated by this equation. Okay. So S is the number of sales, and P is Sam's pay in dollars. So which statements are true? Circle your answers. All right. Now, you could write it like this. Or you could write it like this. So the number without the letter in it, this guy, this is the starting value. The number without the variable is the starting value. So that's what he starts at. And then it looks like his salary, or his pay, I called it pay, his pay in dollars, goes up by $150 $150 for every sale he makes. All right, so Sam earns $150 for each sale he makes. That is definitely true. Because that's his change. His change is $150 for every sale. Sam earns $500. Nope. Sam earns a base salary of $650 a month. Nope. His starting is $500. The vertical intercept is 0, 150. No, the starting value is the vertical intercept. So the starting value is going to be 0, 500. That's the starting value. Starting value is your vertical intercept. So let's see. No, no, and no. Sam's base salary, yeah, is 500. So he starts off with 500, and then he increases by every sale he makes. We okay? Very typical kind of final exam question. All right, let's try another one. All right, Karen is hired at a small sales company. Her monthly pay is calculated by this equation. So it's very similar. Like, this would be cool if you stopped the video and tried this one, right? This is pretty similar to the one we just did. All right, I always like writing the value that we start with plus the change. All right, so before I even look at the choices, I'm going to say this is the starting value. So no matter what, she starts off with 450 and then it increases by 200 for every sale she makes. The starting value is your vertical intercept. So here's my vertical intercept. They're the same thing. Okay. So Karen earns $450 for each sale she makes. No, that's her starting salary. And her slope, or the change, is this right here. This is the change. This is her slope. So her salary or her pay is going to change by $200 increase, because it's positive for every sale she makes. So no, we're going to cross that off. Karen earns a base salary of $200 each month. No, she makes $450 each month, and then it can increase. We're here. Karen earns a base salary of $450 each month. That is true. The vertical intercept, no, that's not true. The vertical intercept is based on the starting salary. And yes, this one, she makes $200 for each sale. Does that one make sense, I hope? All right, let's try this one. All right, Jocelyn gets an iTunes card for her birthday. All right, and she gets to buy songs on it. All right, so I'm hoping you'll agree that this is the starting value. All right, so they labeled this column N and this column A. So the amount on her card is going to be $50. And then it looks like it's minus a certain amount depending on the number of songs she purchased. So let's see how much it costs for a song. So 50 minus 48.71. This is minus $1.29. All right, let's go from here to here. So 48.71 minus 47.42 minus $1.29. So every time she purchases a song, that starting value is going to go down $1.29, depending on the number of songs she purchases. Does that make sense? So this is the starting value. This is the change, negative 129. It's the change or the slope. That's going to happen every time she purchases a song. So which formula would show the relationship between her card and the number of songs she purchases. Do you see it? Do you see that it's C? No, I'm sorry, that's not C. It's got to be B because you need the negative. You can get the pink out. It's B because you subtract $1.29 every time you purchase a song. So it's not D, it's not C, and it's not A. It's got to be B. Okay. All right, let's try another one. Okay. So once you read it, this is where I think, like, if you could just read it and analyze it, like pause the video, read it carefully, and see if you can analyze it, and then turn the video back on, then you'll kind of get a hold of what's going to happen on the final. Okay, these are all types of final exam questions, right? A lot of these are off of old finals. Okay, so what do you think? What do you got? So go ahead and read it, pause, and then answer. All right, so we've got some people are in New York City. They want to go out for New Year's Eve, and they need to know how much money to bring. So this is the formula that is going to help them figure out how much money to bring when they go out to a club. All right, so the starting value is $25. Starting value is $25. So C is the cost, and D is the number of drinks. So this looks like it's $25 from the start, and then the cost is going to increase by 15 every time you purchase a drink. So $25 is the initial value, or the initial cost. Okay. And then what do you think? How much is each drink? So then this means, so 25 is the initial cost, and it must cost $15 extra per drink. All right, I think I have a typo on here now that I look at this. This should be a 5 right here. $15 per drink. To make sure I change that. That should be 15. All right, so the cost you pay the Clothes Club is 15 cover charge. No, so it's not that one because it's $15 per drink. We don't know anything about the time. Okay. The cost he and his friends will pay to go to the club is $40 per person. No, that's not true. Oh, I'm so sorry. That should be 15. I'm going to change that right now. After this video, I'll make a fix. So the cost to pay to go to the club is $25, and then $15 for every drink he purchases. All right. So if he knows how many drinks he's going to buy, then he can kind of get a bearing about how much he's going to need to bring. All right, now you'll also have a graph on the final that you have to interpret. All right. So it says at the beginning of each semester, students at Ohio State University receive a prepaid copy card, just like you guys do. The amount of money remaining on the card is modeled by this line. Okay. So A represents the amount of money in dollars on the card, and P is the number of pages that have been printed. Right? So they say label, so on the graph, label the x-intercept and the y-intercept. Okay. So the x-intercept is and they said technically according to the letters given, what are they called? So the x-intercept is the value that's on the left and the right. But instead of x, they really called it a p. So the p-intercept and the x-intercept are the same. Instead of x, they called it p. So right there it is. The x-intercept or the p-intercept or the horizontal intercept, however you want to think about it, it goes on the left and right. So it looks like it's 1400, 0. Okay, that's your horizontal intercept. All right. The vertical intercept, I'll label this vertical, call that the vertical intercept. I'm used to calling it the y-intercept, but they called it the a value, so it's an a-intercept or a y-intercept, however you want to think about it. So it looks like that is, we didn't go to the left or right, so 0, 70. Okay, so what do they mean? All right, so the p-intercept, this guy, the 1400, 0 means, now the input's the number of pages, so if we print 1400 pages, so the input is the number of pages, the output is the amount on the card, we will have no money left. We'll have $0 on the card. Okay? And this one, 0.70, so the first number is the number of pages you print. So if we haven't printed anything, if we haven't printed any pages, we will have $70 on the card. Okay. The next question is a little bit new, and they ask us to find the slope. So slope comes in two parts, okay? First, is it positive or negative? So that is half. So if this is 2 points, the first part is just saying that the slope is negative, right? Because as you go from left to right, your line is falling, and so that is what's called a negative slope. All right. To find the slope, and this formula will be on your final. You don't have to memorize this. It's the change in the quantity over the change in the time. Remember, it's the change. So, it says find the slope of the line. Well, what is the change? So let's look at this. So the y value. What's the change in the y value? So we start at 0, right? And we go all the way up. I'm sorry, we started here. We start at 70 at the beginning of this graph, and we go down to 0. So the change in the quantity is negative $70. So we're going to remember this is our starting value. Our starting value is 70, and then if we go all the way down here, our ending value, the y value is 0. So we've spent all the money on our card. So what was the change in time, or what was the change, I guess it's not time in this case, what's the changes in the number of pages? Well, here we started off printing 0 pages, and here we've printed 1400 pages. So do you see the change in this is 1400 pages? So the vertical, so I like saying this here, I'm going to do this. Slope, I'll put this on the final too, is the change in the vertical all over, maybe this will help, change in the horizontal. Okay, so the change, and I'll put this on the final, you don't have to memorize this. The change in the vertical, you start at 70 and you go to 0. Do you see the change in the vertical? You start at 70 and you go to 0. That is a negative 70 change. And the change in the horizontal, you start at 0 and you go up to 14. So that's an increase. So that's a positive 14. So the units are dollars per page. Is that okay? So I'm going to, it says, what does the slope mean? So I'm going to pop this into my calculator. just to simplify it a little bit. So this is negative 0.05. You all agree with that? I just put that fraction into my calculator. So this is negative $0.05 per one page. I just simplified it. So negative $70 over 1,400 pages is the same as, and all I did is I put the number in my calculator. So you could say it in one of two ways. You could say it costs us $70 to print 1,400 pages. That would be perfect on the final. That's what the slope means. Or you could say it costs 5 cents per page. It costs 5 cents to print a page. So you could say it that way, or you could say it costs $70 to print 1,400 pages. Either one is lovely. Okay? Let's finish up. Ready? We've got a couple more graphs. Let's see if these make sense. So Helen borrowed money from her aunt to pay for college expenses. The graph shows the amount left on the loan as it's paid off over time. All right, so it looks like she borrowed $13,000. That's the starting value. Does everyone agree with that? The starting value is $1,300 because it's my y-intercept. Starting value is $13,000. Okay, now remember the line is the starting value plus or minus a change times the input. So they wanted this to be A for amount, and this is M in months, I'm assuming. Amount in months. Okay. So which of the following responses describe the situation that the graph is modeling? Well, a loan of $13,000, or $13,000, so that's all the same, is paid off, I don't know, it says at a rate of $130 per month, $100 per month, $15 per month, or $20 a month. Well, how many months did it take her to pay it off? Well, it looks like it took 1,300 months to pay off. So if she paid off $13,000 and it took her 130 payments, or 130 months, how much did she pay back per month? $100 per month. That's the change. Every month, the amount of the loan is dropping by $100. So right here. So she has a $13,000 loan, but she's paying it off $100 per month because it's going to take her 130 months to pay it off. So this horizontal intercept right here, the horizontal intercept is 130, 0. So this is months, and this is amount on the loan. So which one would be best? So the horizontal intercept is the number of months it takes to have the amount of the loan to be 0. Everyone good with part C? Okay, for number 9. Helen writes a linear equation to model the amount she still owes her aunt over time. Alright, so the amount of money she owes. Well, what's the starting value? Starting value is $13,000. What's happening? Well, what's happening every month? Well, it's going to decrease her loan by $100 every month. Do you see which one it is? Yep, it's A. Right? So remember, this is the starting value. and this is the change, or the slope. And it's dropping, that's why it's negative, by $100. Every payment she makes each month. Okay? All right. Which of the following statement correctly describes the vertical intercept? Okay, so here's the vertical intercept right here. All right, if we had to put it as an ordered pair, it would be 0, 13,000. So what does that mean? What do you think? Which one would it be? The vertical intercept is the starting value for the loan. It's always the starting value. So the vertical intercept is the starting value. All right, let's try another one. You ready? Following graph shows a relationship between the amount of money and the number of ice cream treats that are bought. So this is kind of like the latte one. Okay, so would you be able to put an arrow where the vertical intercept is? We okay? There's my vertical intercept. So it would be 0, 50. Oops, it should be a 50. Now, the input, let's put it order pair. So this is the number of ice cream treats. Number of ice creams purchased. That's my input. And my output is the amount on a gift card. Amount of money. I'm assuming like you have a $50 bill in your pocket and it's purely used for ice cream, or the amount of money on a gift card, because it's going down the more ice creams that you purchase. Okay, so this means you have before you start buying ice creams, you have $50 to spend, right? So you have $50 before purchasing any ice cream. So this is the horizontal intercept right here. And that would be 20, 0. So after purchasing $20 ice creams, you have no money left, or no money on your gift card. All right, so the slope, you ready? I'm going to give you the formula. Slope is change in the vertical all over the change in the horizontal. Okay, so we have a starting and an ending value. So we started with 50 and we ended with 0. So do you see that that would be negative 50? Okay? The change in the horizontal, I forgot the H, horizontal, we started with 0 ice creams and then we purchased 20. So this is negative $50 and this is 20 ice creams. So the units for the slope are dollars per, and then ice cream on the bottom. So there's a couple ways to interpret this. We could say we spent $50 on 20 ice creams. if you want to pop it into your calculator, or you could also say, here, I'm going to write it two ways. Negative $50 for 20 ice creams, or negative $2.50 for one ice cream. It doesn't matter. It's the same. I don't care how you write it. I usually like writing it this way. I say, okay, I spent $2.50, or I lost $2.50 every time I purchase an ice cream. I spent $2.50 per ice cream cone, per ice cream treat, per ice cream treat. Or you could say I spent $50 when I purchased 20 ice creams. Doesn't matter, it's up to you. So the equation for the model, so it's always the output, something in terms of the input. So we started with $50. My change, it decreased by $2.50 every time I purchased an ice cream cone. If you want, you don't have to write negative 250. You could write negative 50 over 20. It's the same thing. But we started with 50. We lost money every time we purchased an ice cream treat. Okay. Alright, let's try a couple more. You ready? Alright, Yana's Yogurt. They sell ice cream for $4, or yogurt, and they charge 75 cents for each additional topping. So you have a starting value, and then they're going to charge you money on top of that for every topping. So what do you think? T is topping, and Y is the price of the yogurt. So which one has Y equals, first of all? Because it's the price is in terms of topping. So we need something that's Y equals, and it has to have a starting value of $4. And then you're increasing that price by 75 cents for every topping. Do you see it? There it is. Okay. All right. Let's try this one, and then we just have one more page. I thought this was a challenging one. This one came out of like I think the OCE questions. So it says an online movie service just charges $5.99 per month, like Netflix, right? And then you pay extra. Well, Netflix doesn't do that, but like say Spectrum, you pay a certain amount per month, right? And then every time you want to buy a movie, they charge you money for each movie you purchase, right? So let's look at this movie service. All right, so if we didn't purchase any extra movies, we still have that flat fee, right, of $5.99. So A is $5.99. That should make sense, right? That's your starting value. So let's see, we can cross off this guy because we know A is $5.99. All right. So let's make sure this makes sense. So they said it's $1.99 for each increase in a movie. So if we have $5.99 and we rented one movie, does that make sense that at $7.98? Yes, that makes sense. So let's rent another movie. That would be $9.97. So do you see we rented 2 movies? So B would be 2. So let's see. So it can't be this one because B is 3. So now we're down to these 2. All right, so if we rent 5 movies, how much is it going to cost? So there's my starting, and then we're going to rent 5 movies at $1.99. So we need to find the one where C is $15.94. Did you see which one that is? That's this one right there. So that was an OCE question. I thought that was kind of hard. All right. And then this is also, you can kind of tell by the font, this was an OCE question as well in 4.1. So let's see how you guys would have done on it. It says Sheila wants to lose weight to improve her health. She currently weighs 186, so that is her starting value. And her goal weight is 140 pounds. Okay, so this must be your starting right here at 186. So this is her vertical intercept, her starting value. Okay, so this is the initial value. So 186 is the initial value. Okay, so we're going to have T, so they said, if you look at the problem, T is time in weeks, and this is W is her weight, all right? So how many weeks will it take her to achieve her goal? Well, it says she can lose 2 pounds, so there's our change. Our change is -2 pounds per week. So there's our slope, right? So right there's your line. So her weight is the starting weight plus or minus the change per, in this case, time. So there's her formula. So right there's part C. Her weight is starting at 186, and she's going to lose 2 pounds per week. All right, how many weeks will it take her to achieve her goal? Well, let's pull it out. So 186. So here's 1 week, 2 weeks, 3 weeks. See what I'm doing? 4 weeks, 5 weeks. Whoops, gotta do this again. 186 minus 2. 2 weeks, 3 weeks, 4 weeks, 5 weeks, 6 weeks, 7 weeks. Do you see what I'm doing? I'm just going to keep doing this until I get to 140 pounds. All right. Now, there's an easier way. Now, you can look at this and kind of tell, but look, I'm just going to do an easier way. She wants to weigh 140 pounds. Do you guys mind if we just pop it into the equation and figure it out? So look, let's subtract 186. It's going to take us too long to do that on the calculator. That's bogus. We don't want to do that. Ready? 140 minus 186. Oh, it would have taken us forever to do this. Look how many weeks it would have taken her. So it looks like it would have taken us 23 times on the calculator. It looks like about 23 weeks. That's a long time. Now, does that make sense looking at this? So it's about, she wants to be what, 140 pounds? And so we think it's going to take her 23 weeks. So yeah, this looks like probably it was right about 140 pounds right there, right? There's 150. So yeah, I would say probably around 23 weeks. Let's try it this way. So 23, so if she is at 186 and she wants to get to 140, so she has to lose 46 pounds, right? If she's losing 2 weeks a pound, said that wrong. If she's losing 2 pounds for every week, so for 23 weeks times 2, that's gonna get us our 46. A couple ways to think about that, right? So it takes her about 23 weeks. So it says her health screening is in 4 months. So I would say there's like 4 weeks in a month. So that's only 16 weeks. So will she have achieved her goal? No, not even close. No. So 16 weeks times 2 is 32 pounds. So no. She wants to lose 46 pounds. So no, she will not be at her goal weight. She'll have lost a lot of weight, but she won't be at her goal. And then we did this, and then the slope is the change. So there's the slope. So the slope is the change, per week in her weight. Okay, so she wants to lose 2 pounds per 1 week. Okay, does that make sense? I hope. So what I recommend is that you go back and I would try all these problems again. Okay, try them again without watching the video, and then go back and watch the video again and see how you did on the problems. All right, so I have something. Are you ready? This is it. You're done. There's no more videos. You did it. So this is my celebratory video. Just, we're not in the UK. I'll hide that. But you did it. Woohoo! This is what you should feel like right now. You should feel like fireworks are bursting because you finally watched the last video. You did it. I'm so proud of you guys for sticking with this. It was not an easy situation. I'm really proud of you. Zoom me this week. There's nothing due, so you have some time to watch these 2 videos, kind of absorb it all in. The review is going to be posted on Monday. I'll post it tomorrow. Today's Sunday. I'll post it, and then you can look at some of these types of problems on that review. Okay, everyone. So have a good week. Let me know if you need help. I will see you soon. And let me know if you have any questions on anything in these linear modules. Okay? Take care.